Greetings, everybody. My name is Sophia. Today I will be discussing exercise 1 from the report 7B Introduction to Arduino. I have already set the Tinkercad simulation with the Arduino Uno, the breadboard, a 2020 ohms resistor, and the LED, also known as the light emitting diode. Over here, we're gonna find the code for the Arduino. This is Arduino 1, named as Arduino 1. We go over here to the code. We are already in Arduino 1. Arduino IDE runs on a C++ language. The program of the Arduino is called a sketch. A setup, which is normally here, the void setup. Everything that is in between these curly brackets will run once. This loop, this is called a loop setup. Everything that will be in between these curly loops will run again and again in a loop. So the variable LED was defined as 7. And pin mode, we are saying that our LED, which is already defined as 7, the pin 7, will be the output. Therefore, the red wire was connected to the resistor, and the resistor connected to the anode of the LED. This must be consistent, the pin and the code. Since we define the LED as the output, and over here, we set the digital write, which will help the code to turn on and off in a loop. Here, the LED, which was already defined as pin 7, will be turned on as high. The delay will be for a second. This value of 1,000 represents a 1,000 milliseconds. So this is actually a second. The digital write LED low for turning off the LED will be off for a second. Now, if we run the code, we will see, let's see. Okay. Now we will see the LED turning on and off for a second. There is a possibility that the LED will right now will turn on and off slower based on my internet. So let's start simulation. Now, the exercise continues with the example 4. I have it right here. The example 4, fade a LED in and out. Simulation is already here. This code makes a LED fade in and out using the pulse width modulator, also known as PMW. These pins are known with the wiggly lines. Let's go to the code. So as we see here, the LED was defined as pin 11, because if we want the code to run, especially to fade the LED, it must be in one of these pins. If it is The other pins without the wiggly line, it will not run. Or at least we will not fade as we want to. In this setup, pin 11 is set as the output. So you can see the red wire is already in pin 11, connected with the resistor, and the resistor connected with the anode. In the loop, the first for loop increases the brightness from 0 to 255 in small steps, creating a fade in effect. The second for loop over here decreases the brightness back down to 0, making the fade out. Each step has a short of 10 milliseconds. This is a delay of 10 milliseconds. So the change looks smooth. Together, this creates a continuous fade effect for the LED. So let's start the simulation to see the fade effect in this LED. USB is connected. That means the code is uploaded. Let's zoom in to see this effect. Yep, there we have it. The LED fading, increasing the brightness and decreasing the brightness. So there you have it, folks. Thank you for listening. This is Sophia explaining exercise 1. Thank you for your attention. Goodbye.